These two things look almost identical. Same color, similar texture, both dark, both earthy smelling, both technically made from decomposed organic matter. And if you've been gardening for any length of time, you've probably seen them compared online. And the comparison usually goes one of two ways. Either someone says worm castings are just overpriced compost and you're being scammed, or someone says worm castings are basically magic and compost is for amateurs. Both of these takes are wrong. The actual science tells a much more interesting story. These two things are not the same product. They're not even produced in the same way. And the differences between them matter for your plants in ways that most gardening content never explains. I'm Sonny, this is Sunnyside Soil, and I want to show you what the research actually says. Let's start with what's actually the same, because that's important context. Both compost and worm castings are the result of organic matter being broken down by living organisms. Both produce a dark, humus-rich end product. Both improve soil structure, they increase water retention, and supply nutrients to plants. Both are dramatically better for your soil than synthetic fertilizers because they support biology rather than bypassing it. So if you're choosing between using finished compost and using nothing, well, yes, use the compost every time, no question. But the comparison between compost and castings isn't compost versus nothing. It's about understanding what each one actually delivers and why. The fundamental difference between compost and worm castings starts with the process that creates them. Traditional composting is primarily a thermophilic bacterial process, hot composting. This is the composting that generates temperatures between 130 and 160 degrees Fahrenheit inside the pile. The heat is produced by aerobic bacteria consuming organic matter at high speed. It's effective at breaking down material, killing pathogens and weed seeds, and stabilizing carbon. But the heat also kills a significant portion of the beneficial microbial community that was in your inputs. Vermicomposting or worm composting is a mesophilic process. It happens at ambient temperatures, typically between 55 and 77 degrees Fahrenheit. Worms are doing two things simultaneously. They're physically grinding organic material in their gizzards into smaller particles, which dramatically increases surface area for microbial activity and passing that material through a gut environment that is extraordinarily rich in bacteria, enzymes, and other microorganisms. The worm gut is the key to everything. It's not just a digestive system. It's a biological transformation chamber. Research has shown that the microbial community inside a worm's gut is fundamentally different from the microbial community in the surrounding bedding material. What comes out the other end, the castings, has been inoculated with that gut community. So, compost is the result of bacteria and fungi breaking down material under heat. Castings are the result of material being physically processed by worms and microbially transformed by the worm gut. Same raw inputs, completely different biological pathways. And hey, here's a quick pitch. If I've convinced you that worm castings are a good product for your garden, then you're in luck because we sell them here at Sunnyside Soil. I'll leave a link in the description below. Here's where it gets interesting. Multiple peer-reviewed studies have measured the microbial populations in worm castings versus finished compost, and the numbers are striking. A 2009 study published in the Journal of Environmental Biology by Haritha Devi and her colleagues compared microbial populations and enzyme activity in vermicompost and conventional compost made from identical inputs. The same fruit pulp, the same vegetable waste, and the same cow dung. Vermicompost came out ahead on every measure. Higher microbial counts, higher enzyme activity across the board, and peak activity reached nearly 3 weeks earlier than in conventional compost. A separate review published in Springer Plus, drawing on multiple studies, documented that castings consistently show higher microbial diversity and higher populations of specific beneficial organisms, particularly bacteria in the genera Pseudomonas, Bacillus, and Nitrosomonas, than thermophilic compost made from equivalent inputs. Oh great, Sonny, thanks for the fancy words, but why does it actually matter? Because those specific bacteria perform functions that are directly relevant to plant health. Pseudomonas species produce compounds that suppress soil-borne pathogens. The bacteria are essentially doing plant disease management. Bacillus species are known plant growth promoters that produce hormones called auxins. Nitrosomonas are nitrifying bacteria that convert ammonia into nitrate, making nitrogen available in the form plants actually absorb through their roots. Now look, I'm not going to lie to you, finished compost does contain bacteria, but the thermophilic process selects heavily for heat-tolerant organisms. The slow, cool, gut-mediated process of vermicomposting, well, it produces a broader spectrum. There's another piece to this. Castings are also rich in fungal hyphae. That's the thread-like structure of soil fungi at much higher levels than most finished compost. And fungal networks are critical for nutrient cycling, particularly phosphorus. Plants that are connected to active fungal networks access phosphorus dramatically more efficiently than plants growing in biologically depleted soil. This is the core reason worm castings punch above their weight nutritionally, even though their raw NPK numbers, their nitrogen, phosphorus, and potassium percentages, are relatively modest. It's not the nutrition, it's the biology delivering the nutrition. There's a chemical dimension to this comparison that also gets overlooked. Worm castings are consistently higher in humic and fulvic acids than equivalent input compost. These are complex organic molecules that form during the decomposition of organic matter, but the worm gut accelerates and amplifies their production significantly. They increase the cation exchange capacity of your soil, which is a measure of how well your soil can hold onto nutrient ions and make them available to plant roots rather than just letting them leach away. They chelate minerals, meaning that they bond to iron, zinc, manganese, and other micronutrients in a form that plant roots can actually absorb. And they stimulate root development directly. There's solid research showing that humic acid application increases root biomass. Fulvic acids are smaller molecules that penetrate cell membranes. They carry nutrients directly into the plant. Think of them as a nutrient transport system that works even when soil conditions aren't perfect. Now, compost does contain humic and fulvic acids, certainly more than bare soil, but castings contain them at significantly higher concentrations. And this is actually one of the reasons that we're exploring a standalone humic and fulvic acid extract here at Sunnyside Soil, because the concentration in castings is high enough to be worth extracting and applying directly. Now, here's the part that surprised me when I first read the research. Worm castings contain plant hormones, specifically cytokinins and auxins, two classes of hormones that regulate plant growth, cell division, and root development. These aren't added. They're produced during vermicomposting, partly by the microbial community in the worm gut and partly by the worms themselves. A landmark 1988 study by Tomati and colleagues, published in the journal Biology and Fertility of Soils, tested aqueous extracts of earthworm castings on ornamental plants and documented what they called a hormone-like effect. The plants showed growth patterns consistent with auxin, gibberellin, and cytokinin activity, faster root initiation, increased root biomass, and accelerated development. The researchers concluded that biological effect was linked to microbial metabolites produced during vermicomposting. That study has since been cited widely across the soil science literature, and the findings have been replicated repeatedly. Plants grown in media amended with worm castings, they exhibit faster germination, higher germination rates, and more vigorous early root development compared to plants grown in equivalent nutrition without castings. These effects appear even at low application rates, sometimes as low as 10% castings by volume in a seed starting mix. Compost does not contain plant hormones at meaningful concentrations. The thermophilic process it breaks them down. This is another category where the biological pathways of vermicomposting creates an outcome that hot composting simply cannot replicate. This is why castings are so effective in seed starting mixes specifically. It's not just nutrition, it's the hormonal signaling telling seeds to germinate and for roots to grow. All right, that was a lot of information. So given all of that, how do you actually think about using these two products? Compost is your high volume soil builder. Use it when you're amending large beds, building new growing areas, or improving soil structure at scale. A good rule of thumb is 2 to 4 inches worked into the top 6 to 8 inches of soil when establishing a new bed. Compost is also your best tool for improving clay soil and sandy soil alike. It physically changes the texture and opens up pore space over time. Compost is also affordable enough to apply generously, and you can make it yourself at scale. It's the foundation layer of a soil building strategy. Worm castings are a precision tool. You don't use them the same way as you use compost. Not because they're too powerful, but because they're expensive enough that using them like bulk compost, it just doesn't make sense. Where they shine, seed starting mixes, transplant holes, top dressing of established plants, and compost tea brewing. In a seed starter mix, 10 to 20% castings by volume is enough to make a real difference in germination and early root development. For transplanting, a small handful in the hole before setting the plant in gives roots an immediate biological boost. As a top dressing, a thin layer around the drip line of established plants, watered in, is one of the most efficient ways to deliver living biology directly to the root zone. Castings are also the best compost tea inoculant. When you brew an aerated tea with the base of worm castings, you're exponentially multiplying that existing microbial community. The result is a liquid amendment that delivers billions of organisms per application across a large area at very low cost per square foot. And really, in my opinion, the best approach isn't choosing one over the other. It's using compost as your structural base amendment and castings as your biological precision tool on top of that. Build soil volume with your compost, then use castings strategically where biology matters the most, at germination, at transplant, and in your highest volume growing areas. So worm castings versus compost. Same shelf, similar appearance, completely different biological products. Compost is a thermophilic process that stabilizes organic matter efficiently and builds soil volume at scale. It's essential. It's foundational. Use it generously. Worm castings are something different. They're not better compost. They're a distinct product with a distinct biological profile. Higher microbial diversity, higher humic and fulvic acid concentrations, plant hormones that compost doesn't contain, and a fungal community that changes how your plants access nutrients. The people who say castings are overpriced compost are looking at the NPK numbers and missing the biology altogether. The people who say that castings are magic and don't need compost are skipping the foundation. Use them both. Know what each one does and let the science guide you rather than the marketing. If this gave you a clearer picture of what's actually in your soil amendments, then hit that thumbs up. It genuinely helps this channel. And if you have questions about application rates or building your own vermicomposting system, then drop them in the comments. I'm Sonny. This is Sunnyside Soil. Your soil is alive. Feed it accordingly.